Okay, I'm recording. We're still waiting for T-Bone. Can somebody text him? Hong is eating, yeah.
I know he is coding, so I just remind him that time to start.
Ellen, okay, I know you are hearing us, but you can't talk. We keep you as an attendee because it's the webinar type of the session. And E, also welcome. Thanks for joining us. I think that we have like, okay, Cheryl is here. Very nice. Okay, great. All right, guys, let me get started. I'll say a few words about who we are, why we actually joined tonight, right? And then I'll pass the mic to James, who is the course creator of AI201, the program that four guys, Fantastic Four, Vishal, Sasha, Adeboy, and Greg, they graduated this program, okay? So I'm sharing the screen and then passing mic to James.
Okay.
Wait, let me actually say a few words. All right. First of all, guys, thanks for joining. Thanks for having the time. It's 7 o'clock after the work, right straight here. And we are Unpack. So our mission is, first of all, to make AI and Web3, essentially any future technology relevant to business professionals who are very busy, but they want to stay relevant in this ever-changing technology-driven world. And we believe that cohort-based learning, where you essentially come together as the community, together with mentors, and with all that community support, we help you to succeed through your upskilling, right? If you want to become more technical with AI, or even if you have the goal to become AI developer, we provide you the full support, the resources that we allocate here in our community. Moreover, I will show later that you can be also the mentor. So we utilize student mentor pipeline. We train our students to become the mentors to enable more students to come and learn and eventually grow to AI developer in this AI learning track. For Web3, we will talk more about, we have very exciting news. We'll launch a blockchain course next week. But right now, all the attention to our AI community here, right? So one of the values, to the business professionals is the cohort-based learning programs. We have also expert sessions. We bring industry leaders to talk about how they implemented AI, what's changing in the industry, how to stay relevant. Community lounges, just we normally gather and talk what really matters in technology in life, what's going on in life, and we are joining for that on Metaverse. Medium publications, the part to help our AI 101 students to present themselves as the AI practitioners. Okay, so AI 101 is just entry-level training program, and it's very important to start showing yourself as the sparring AI practitioner. So prepare your LinkedIn network, your friends that you are upskilling yourself and getting into the AI role, right? Also, we have demo days, the one that we are attending now, and we also led our community members to present AI and Web3 use cases. So right now, we can't really enjoy offline meetings. Like we have the community scattered in Shanghai, in Beijing, Shenzhen, but we all have this cyclical lockdowns that kind of really hard to manage offline meetings here. And this is what we are proud the most is our education pipeline. So the projects that you guys will see tonight, they come from the graduates of AI201. So they went through AI101, which is kind of like help them to understand the limitations, possibility of AI through building their AI mini projects, getting these hands-on skills. So then they went to the AI201. They were practicing those skills, getting more in depth into data preprocessing, data preparation, building the model architectures in order for them to build their own project now, right? And now these guys will be granted the role of the mentor assistant and mentor, so now they can keep learning AI, but also teaching and mastering their skills. Moreover, as the mentor and mentor assistants, they will be able to earn some money and essentially covering the costs of their fees that they provided as the students. So if you are interested in upskilling AI, this is the QR code. Please scan right now, and I'll be passing the mic to you, James, while you can introduce yourself. I just want to let this QR code to stay for 10, 20 seconds more.
Okay. Yeah. Thank you everyone for joining in this webinar. I am very happy to introduce this course, which I am the designer of, along with Mauricio, who is the main mentor for this cohort. And it's a really interesting thing because a lot of the students here are interested in technology, but learning it turns out to be a different path than you'd typically expect. So it's heavily focused on solving problems and doing things that are actually really relevant to people. So we're going to have 4 presenters this evening, and they're each going to talk about how they, I guess, their journey through this course and what they did. So with this, I'd like to start with Greg, who has brought his own data to this course related to his business and is doing something really practical, which is using AI models in order to get insights out of his data and be able to prove things versus just kind of having intuition. So let's see how Greg is doing on this journey. So Greg, would you like to present first?
I will do just that. Let me make my face a little bit smaller here. I still want to be in frame. All right. Good to meet everyone. I'm excited to kind of go over this. It's been a journey, to say the least, getting used to using AI and going through and completing this course while also kind of using my own data. So part of what inspired me to do this, again, I went through the DL101 course, and it made me realize that we have a lot of data that we use in my company, which is a furniture company. And we have a lot of data and we don't always know exactly how to use it, okay? Now, the stuff that we do frequently use is like the numbers for deliveries. So the amount of deliveries, amount of exchanges, and amount of returns. And with that information, we can sort of determine a product's performance, okay? So, and again, here's just kind of a brief profile. So again, the problem that I presented here is that on occasion, quality issues can be found that lead to a customer returning or exchanging the product that they purchased, okay? So we use an exchange and return percentage to give us an idea of how a product is performing, rather than just sifting through customer comments and looking for positive versus negative. This is a more quick and effective way. So in my experience, it seems that some items tend to have more defects than others. So regardless if we test it, if it's always inspected 100%, and if it's constructed with, quality materials, some items seem to be affected more than others, just as a general rule. So I wanted to dig into the data a little bit deeper and see. I wanted to ask this question. are there features inherent to a product that can determine whether it will have a higher exchange and return rate? Now, when I first constructed this model, I constructed it as a classification model. And I wanted to see specifically if a product was going to be over or under 6%. 6% is sort of like a golden number that I've been following. If a product is under 6%, it usually means that that product is performing optimally. If it's over 6%, we have problems that we need to solve. As time went on, this actually ended up becoming a regression model, but I'll get into that later on. So these are the features. These are the features that came up with my model, and these are the features that I included in the data set. The SKU, or the product description, which vendor is making this product, is it KD or not KD? KD just means that a product is disassembled before we ship it. And then at the end of the supply chain, either the delivery driver or the customer themselves has to put it together. So that's what KD is. Just think disassembly. I ask also whether or not the product has power. Are there any electrical components, power switch, anything like that going with the product? Does it have a dark or light finish? What's the assembly size, primary material? And I also added in low, mid, high production cost. I added this towards the end of my experimenting with this model. It's probably going to be coming into play more as I continue to play with this data set, because I am not done by a long shot. So when I started this, my hypothesis, what I thought was going to happen was that certain features would likely lead to a higher exchange return percentage. Items with power, items that need to be assembled by the customer, as I mentioned earlier. In particular, I was wanting to see how fire pits would end up. Would the AI pick up that fire pits tend to have more issues? Because in my mind, fire pits are probably one of the more complicated products we sell. There's power, there's flame. It involves the end user needing to actually operate it and know how to operate this thing in order to get it to work right. And if any of those things fail, it's liable to be returned. I also, and I didn't add this here, but I also predicted that maybe a lighter finish would also have an effect, because if you have a scratch on something and it's got a white coat of paint, then you're more likely going to see that scratch than if it was a black product. Preferably, I would also like to see which vendors have been underperforming according to the model. And like I said at the top, this ended up becoming a regression model looking to predict the continuous variable of how high the exchange return percentage or how low it would be. So any questions up to this point before I go on into the model? Okay. So I went ahead and at the start of this, like any of these notebooks, I imported the libraries. I used pandas, and I ended up not using NumPy towards the end of this, because there seemed to be some confusion in the library between pandas, NumPy, and also PyCaret. But I did use it at first to help encode some variables, and I'll get to that in a minute. I uploaded the data set, as you can see here, and we have the data set head right here, kind of listing out the different variables, delivery method, the description, whether or not it's KD, again, whether or not you have to assemble, the finish, the material that's being used, and also the assembled height. So I ended up with 529 rows. That would be 529 different products. And you can see how I've divided the training and testing set right here. And I opted to use, you can see here, 0.9. So 90% is for training. And then we have a testing percentage of 10. So I set this up as a regression. And I chose to, after some playing with this, and it took time, I ended up ignoring several different variables, including the number of exchanges, returns individually, and services. These, obviously, if you have a high number of exchanges, of course, it's going to indicate a higher exchange and return rate. So that was dropped because I wanted to look more into the features, not necessarily the numbers, which of the features were creating a higher exchange return rate. I also dropped services. Services, just to explain, when we count a service, that's when we send a technician to the customer's home in an attempt to repair the product. So that's what a service is. I did not add them into this model because I do not have a weight to attach to a service call. If I had a numbers, for example, if I had a monetary amount that I could attach to this, then I would have included that just to see how it was correlated. Moving on, these are the models that I compared. I ended up using a random forest regressor. And we can see here, I ran this model and I tuned it, and I concentrated on the R squared. R squared basically, and this is how I was trying to see which specific model would perform best. R squared basically looks at the variability and determines that measure is used as a determinant of how much of the variability can be explained by the model. So I was hoping for a higher amount. Every time I ran it, it kind of went up and down. But as you can see here on my first plot model, I saw that so this is kind of like the results ended up being. So the first time I ran this, we had an unusually high focus on one specific theme, one collection called Portugal Cove. And then, of course, deliveries were right after that, height and cubes. So I found in the data that Portugal Cove actually took up a disproportionate amount of the high exchange return items. So part of that is because it was, well, there's a variety of reasons. I'll get into that. And I proceeded to encode KD after this to label it as either yes is a value of 1 or no is a value of 0. That made a slight difference. As you can see, Portugal Cove dropped quite a bit, and deliveries became the overriding factor. After this, I decided to remove a couple of things. I ended up removing products that were being phased out to sort of bring a little bit more balance to this. And what I mean by products being phased out, I mean products that were no longer shipping, and we are selling only a couple, but we still have a lot of them coming back if they're being returned by customers. So basically it distorts the data in the process. So I took those out and I got this, which is nearing more to my my original hypothesis. The last thing I decided to get rid of on number 4, which was my most successful plot, was deliveries. So what about a product that's never been delivered before? Because what I would like to see is if a new product, which has no history, which features are going to impact it the most? Which features are going to give it a low exchange and return percentage or a high one? And on the 4th attempt, I removed deliveries, and this is what I found. So you can see that this vendor, FRIT, was a big indicator of if this was going to be a poor performer. Assembled height and Portugal Cove shows up again, and more. The 5th and final attempt, I'm still working on this, and this is where I tried to add in darker light finish as well as production costs, where I separated the cost between low, mid, and high. But again, this is what I'm still working on at this point. So to evaluate the model at the end of this, what can be inferred? So my hypothesis, the original one, was challenged. It seems that from the data, from most of the plots, including the 4th one, size matters, color doesn't so much. KD dropped in and out of importance throughout my times plotting this, and teak seemed to be the most defective material. Although I think that could be due to some other features included in those items, so I want to dig in a little bit further to look at that. But one thing that did seem to get confirmed is that fire pit products correlate with a higher exchange and return percentage because this vendor, FRIT, makes specifically fire pits, and which is what led me to that assumption. So in the future, to make this model better and better, one thing I'd like to do is give less weight, as I did this time around, getting rid of some of those higher exchange and return items because they may be distorting the data. I'd like to try new regressor models, and I would also like to go about looking at how to make those other variables that I discussed at the very end there, including the price and dark or light color, encoding those and seeing if they might give me different results after working on the regression model. And that is the end for me. So I'm happy to take any questions if anybody has them.
Okay, thanks a lot, Greg. That was really interesting. It's very practical, very grounded, and shows kind of a transition that comes from using Excel as a tool to using Python and Pandas, and how it could really power up your use of data in your business. Excuse me. Okay. Mauricio or Thibault, do you have any comments about it? What do you think?
Oh, I have the comment here. Greg, so you build a model. Seems like there is some decent result. And what will be your next steps, the company-wise, in terms of the implementing that? What will be your strategy or your thought process here, at least?
I'm all open to ideas on how to get stakeholders involved in the company. Actually, about this is I want to make sure that the quality team gets involved because I work with the quality team a lot in the US and helping them sort of sort through the data and look at what our best performing products are. But I think a lot of this is very manually driven and it's very time consuming. So if I can get a decent working model, I would like to pass this on to the quality team and kind of show them that this is a way that maybe we can save some time and evaluate which of our vendors are best performers. But besides that, when I took out deliveries, part of the purpose of that was to determine, like I said earlier, a new product that has never been on the market. If we are looking to have a new product, for example, made at that vendor that I mentioned earlier, FRIT, and we know that making a product there usually ends up with a poor exchange and return rate, if the buyer knows that, maybe they'll make a decision to purchase elsewhere or to do due diligence before they start manufacturing this product.
Okay, thanks. Yeah.
If that answers your question.
Yeah, I mean, you have the ideas. That's really important here, and of course, that involves communicating a lot with all the stakeholders, as you mentioned. And I think you have already like the right team to approach, and of course, like you'll figure out how to better structure your AI pitch there.
If all else, if everything else fails, what I learned from this is patience with computers, which I think is very important. I did not have that before.
Definitely. All right. Thank you so much, Greg. Our next presenter is going to be Attaboy. Attaboy has an incredibly interesting project that has to do with chemistry and pharmacology. So this is a very rigorous field in terms of experimentation and everything that goes on. And it's quite exciting to see what AI can do in this field. So without any further ado, here is Attaboy.
All right, let me share my screen.
Yes, we can see you now.
Yeah. Can you see my screen?
Yep, can see it fine.
All right.
You have to
Good.
switch back, other boy. Switch back to
That
the now like we see as the as a presenter. So you need to like show as a viewer for us. Just switch back in display setting
On the top,
on the top display settings. Yeah.
yes.
Yeah. Okay.
Great.
All right, you can see the
good
screen
now.
right now, right?
Yeah, it's good now.
Great. Okay. So Adebo is my name, and I worked on a project titled towards drug discovery, a predictive drug dosage application. And this project is notably used in the field of pharmacology and drug discovery. And I'll just take you through what I did in this project and the nitty-gritty of the work that was done. This takes me to the introduction. Now, this project focuses on creating a machine learning model to predict drug dosage. And this actively deals with a way and method to activate a therapeutic target. And this target is called Peroxism Proliferator Activated Receptor, gamma in this case, which is also known as PPAR. And these receptors are involved in several diseases in the body. And here we are able to examine their structural properties and their biological activity. Now, what are peroxisome proliferator activated receptors? They are expressed in many organs in the body, and they help to regulate diseases and ailments. And also, targeting them could either be a corrective or preventive measure in clinical diagnosis. More so, they are ligand activated transcriptose factor, and they regulate genes and also useful in endocrine disruption. Now, they play essential roles in regulation of cellular differentiation and development and metabolism also. Basically, PPARs are expressed in many organs in the body, and the upregulation or downregulation of these PPARs are very essential in treatment, in corrective or preventive clinical diagnosis. And, overexpression of this PPAR would lead to many other diseases, which we'll examine in the course of this presentation. And the underexpression of these PPARs also would result into some other diseases. So activating them through drugs is something that is common in drug discovery and pharmacology these days. So these are PPAR concerned organs and their corresponding diseases, looking at hypertension, diabetes, ulcerative colitis, muscle atrophy, liver cancer, and hepatitis, then adipose tissue inflammation, and so on and so forth. So this leads me to the data processing employed in this model. Now, clinical data from Chamber was imported from the Chamber database, and more also PPAR gamma bioactivity data was imported from, extracted also, and processed for this model. PPAR dataset and codes from GitHub were employed also, And using pandas, I use this to manipulate, to clean, and to arrange the data into usable data frame. Then also, molecules were selected based on the EC50 concept. And this is a way of comparing drug potencies to see or to determine which molecules in the drug or which drug is more potent than the other. And the effective, the EC50 is an effective concentration to produce a 50% of the maximum response in any target at all. And the target we're looking at here is the Peroxism Proliferator activated receptor, which is the PPAR. Now, looking at the model, exploratory data analysis was done using the PPAR data analysis, and using packages such as NumPy, RDKit, Seaborn, Matplotlib, and basically based on the Lipinski descriptors, and checking some few codes that were run through the model. Now, to say this or to explain this, I practically used about 4 notebooks in preparing this model, and then so I'll just show you some few codes that were essential in the course of this model. Now, in notebook 1, I work with the data, importing tabular data, processing them, and arranging them, labeling also, and arranging into usable data frame. And this data was imported from the Chamber Web Results claim, and this includes deleting and the missing data also. Then in notebook 2, I calculated the Lipinski descriptors, which are essential for determining drug potencies. And again, looking at the model itself, the training and the test model, I separated these based on the 80 to 20% ratio. That means I used 80% of the data for model training, while the remaining 20% was deployed for model testing. And then thereafter, I compared the machine learning, different and various machine learning algorithms to see which is best and which could be more formidable in this model. Then this takes me to the results. And these results are interesting in the sense that they actually show the effectiveness and the efficiency of this model. First and foremost, I plotted the graph of the bioactivity class, which includes the full agonist and the partial agonist in the selected molecules. Now, the implication of this is that for this model to have selected majorly or to have selected and identified majorly full agonist, it means that it is highly efficient and it is highly effective. It means also that when these molecules are employed or are being used for drugs to target the PPAR, the full agonist takes preeminence and it works better than having a molecule selections of partial agonist. Now, moving forward, I plotted the scatter plot of log P and the Mann-Whitney value. And this shows that just like the bar plot, the full agonist represents and takes a major spot in this. And this further confirms that the efficiency of this model is high, and when these molecules are selected, the full agonist works better and they are more effective in targeting the PPAR genes. Now, thereafter, I looked at the EC50 concentration of the molecules that were selected, and it gives a good result in the sense that the full agonist here overshadows the partial agonist, and you know, the EC50 is a model or a concept that describes how fast the drug can work, how fast the molecules in this drug can be released in the body. And having majorly full agonists selected and identified, it shows that when these molecules are being put together and being used in this drug formation, it has a higher potency of fast release in the body and thereafter being effective and efficient. And here I looked at the Mann-Whitney U test, which is an important aspect of a regression model. And here also we can see that the though not so much of a worry in this place, because the Mann-Whitney U test does not really define totally the potency and the effectiveness of the drug, but then it shows a considerable and a high level of effectiveness here. Then
Okay,
here
this is looking really interesting.
The NOMH receptors here, looking at
Okay.
the bioactivity class that was selected. Hello?
So yeah, this is looking really interesting. What are some of the implications of all this?
Yeah, the full agonist and the is a major concern when it comes to drug discovery and pharmacology, because it means that when we have major full agonist in a molecule that composed in a molecule of a drug, it means that it is highly effective, and the dosage that will be required to treat a particular disease will be lesser than when you have more partial agonists in the composition of
Right.
So
and then, like you were saying, this is normally a trial and error process that takes years or decades to do.
Oh yeah. The machine learning has actually increased the process of drug discovery actually, because you know, before this time, drug discovery takes maybe like 10, 15, 20 years before a drug could hit the market. But these days, through machine learning and through precise modeling like this, pharmacists have been able to achieve lesser years and periods. These days, it takes maybe 5, 6 or less years for a drug to hit the market. And we can see the effectiveness of that during the COVID-19 vaccine production also. Learning models were largely deployed in these systems and in this in the production of the vaccines, and it makes it faster instead of having the usual 10, 15 years. Through the effective modeling, it shortens
yes, that's really relevant in today's world.
So
thank you a lot for sharing all this. It's been really interesting.
Looking at the model performance, I also now just get into the end of the presentation. Looking at model performance, I looked at the R squared, and you know, it's a measure of error, and it shows that the decision tree regressor coupled with random forest regressor is high in this particular case. And as we can see, all the models or the algorithms are listed, and it selects the best performing of these algorithms in this case. Then also the root mean squared error for the random forest regressor, which was used, I could see that the root mean squared error is less. And this means that this model has less error, and it could be said to be formidable and very, very high performing. Yeah, the time taken, the random forest regressor which was deployed takes a less considerable time compared to the extractory regressor and the MLP regressor. So, and this is partly because the data set used in this model is large, because the tabular data is large and they are big data. So, all in all, from these evaluations and from this model, we can see that the model is high performing. It's formidable also. So, thanks for listening. I'll be glad to receive questions if there's any.
Okay, thank you so much. Yeah, feel free to ask questions in the comments, and Attaboy can answer them. This is really fascinating how with this kind of open data sets, anybody can go in and start to do these kind of experiments, which is something we really encourage in these cohorts. Okay, so thank you so much, Attaboy. Okay, our next presenter is Vishal. Vishal has a really interesting question about the crypto economy and how it relates to what we consider the traditional economy, and does this using not just discussion, but rather looking at data and seeing what the data says. So let's yield the floor to Vishal.
Everyone can hear me?
Indeed, we can.
Can you hear me?
Yeah, we can.
Yes, we can.
Yes.
All right, great. Good evening, everyone. And before I start, my apologies. My network seems to be poor at the moment, so I will only be sharing the screen. And even in between, it could be a dropout, but that will be a couple of seconds only. Let me know if that happens by WeChat. So as you can see, for me personally, I'm a business professional without any link with the IT or coding. And my personal interest to make some investments either in the stock market or crypto economy for a couple of years. So when they asked us to choose a topic, I picked up this because I picked up this topic because I think this is very interesting for me and in general. As you can see from the picture, we are talking Ethereum and also the traditional economy. On this page, on the left side, you will see what we call it as traditional economy. So as you see in last couple of months, because of inflation, the interest rates are going up, and all the stock prices across the world are going down. 2 years ago, when the COVID started hampering the economy, then the gold prices start to go up, and crude oil also has some relationship. So in general, all these elements on the left side have some interrelation, and they have been studied in detail, and there are very well justified correlations between them. So we can say the currency or the money, the US dollar, for example, is going in the left side of the economy. Then what happened last 10 years or so, the crypto economy and the recently NFT coins start to come in, and the same US dollar started to flow in this direction also. So the objective of this project is to identify whether there's any relation for the pricing of the cryptocurrency with the traditional economic indicators. So we are just trying to explore a yes or no. For the pricing, it's for the data. We looked at the data sets. It's not so easy. There is no set data because we picked many economic indicators. I could not find them together. So I went on the open sources like World Bank, Yahoo Finance, and picked in different formats. It's not so easy because they all have different time frame, different formats. So, but anyway, that's the first step. We collected them. And this on the page you are seeing is the majority of the work, the time I spent. I'd like to mention that we use pandas because pandas can have more than 15 kind of formats it can read. It's very helpful tool, library maybe. And on the left side is the complete process. We picked the model, read through pandas, then we choose the model through the date, and then we selected the date. So if you look at gold, it can go up to maybe more than 100 years pricing data. But if you look at Ethereum, it's more couple of years. So we need to bring them at the same date range. Then we did have to drop some unrelated columns. And finally, we merge all those different Excel file with the date in a single file. It's a merge data. In some cases, we needed to backfill some data, like the initial time period for BNB, that's Binance coin, because which is a very $2 or $3 in the beginning. So we just backfilled it just to complete our data. And then we run the models. So what you are seeing here is those very simple model. It's not the machine learning or artificial intelligence output. This is just to show that at the x-axis of time, you can see the during last 4 or 5 years, how the different macroeconomic indicators perform. And it's very obvious, it's very difficult to find a very similar trend in them. So we pick this data into one file and we run the regression analysis. On this page, what you are seeing is a comparing different model. Left side, you are seeing the Huber Ridge LR. We were focusing on the root mean square value, that is RMSLE, and we could pick any of the model to run further analysis. So we picked Huber. And then the process of machine learning is the model will be created after we choose it, and then it will be tuned. So that's how we come to a final model. So this, I think, is the most important output here on this page. It's telling us that our target parameter, which is Ethereum. Ethereum is a rather world's second largest crypto coin and rather stable. So what kind of correlation it has with different economic indicators? So you can see it has the highest correlation with BNB, Binance, which is another coin. But in terms of crude, interest rate, gold price, NASDAQ, stock market, it has no correlation. So what we call this graph is a feature importance plot. And it kind of proves our hypothesis that the crypto economy runs very independently of the traditional economy. After we create the final model, we can also save it as a .pkl file. That's what we did. So it means if we want to extrapolate the model or however low accuracy, but we want to predict the price of Ethereum, we could pick this model and give to anyone who. So we don't need to give all the data and all the coding. We just give the final model to anyone, and it could be used by anyone. So as a conclusion, our crypto economy is very independent from the traditional economy. This was the original question we have. And if Ethereum coin has any correlation, it's with the Binance coin. We think the model, we picked this as a project, but this is a very real economy, very large question. And I'm sure there are billions of dollars being poured into answering this question. So I do not expect that in 5 weeks boot camp I can answer that. But we got a very good understanding on how to collect the data, clean the data, which is like 70 to 80% time consuming job, and then how to use those models. So I think going forward, if someone has more interest, we could also include additional parameters like price of electricity, price of these GPU units, chipset. And for example, some of our classmates commented that original innovation for Bitcoin happened because it gives you anonymity for money transfer. So perhaps if there is a way to check how much is people are free to move the money without any regulation, it could also impact the price of coins somehow. So I think this bootcamp give me quite good push in terms of understanding and making myself a bit more confident that even with some data and with a question, if I start, I can go to Google or various sources to have an understanding. And also, I like to thank our mentors and the teacher and our colleagues who help us complete this. So thanks a lot.
Awesome. Yeah, thanks so much for the presentation and learning as well. Again, one interesting thing about entering AI is you can do it from what you already know. So then it's not like you have to learn everything from the ground up and like what the fundamental mathematics are. You can enter it from like your already existing knowledge, and you can apply it through analogy to concepts that are in AI and everywhere. So this has been really great. And yes, working with the data is going to be one of the larger parts of doing all this. So if you could do that and you have the grit, then it is for you. Okay.
Thank you.
Yes, yes.
Also, another comment, just a reminder that it is great that the students are proposing projects based on their personal interests. If people in the community have aligned interests, just please reach out. It will be good to create groups and extend, move forward in these projects, because they are all having like open-ended questions, and there is definitely more work that can be done, more learning to do.
Absolutely. Absolutely. All right. So last but not least, I would like to give the mic to Sasha, who is doing a project with NLP and getting to use text data to solve a really relevant problem.
Thank you, James. Thank you, everyone. My name is Sasha. I'm natively born Ukrainian, so that is why my English is not the best. So you'll hear a very strong accent, and I hope you can really enjoy the presentation. I will try not to overrun, and just to say a few words about myself. I've been in the corporate business for quite long, so that is why the first thing, I didn't prepare any PowerPoint, but I hope you see my screen now. And that is PDF, because we are doing PowerPoints every day in our daily life. So my project, I call it Start to the Bridge. And actually, I'm very passionate of building teams and growing the teams, growing professionals who can really succeed in their life. I've been doing this quite long in my professional life. And during the last 5 weeks, together with friends in AI bootcamp, I think I have learned a lot, and I would like to share with you. So that is one student's 5 weeks journey to build a dream. And we've been discussing what will possible to do here is tried to think how we can combine the best talented people with the best companies using the modern tools we have in our toolkit. So maybe it's not something that you don't know, but bad company corrupts good morals. And I saw it a number of times in my life when the people who have very good talent, very good skills, but they're not put into the right environment and they cannot grow. And that was one of my inspiration, really, to understand how technology can help with that. So what we did, we select the company. That was the company from a Fortune 500. I don't want to say the name, but maybe you can guess at the end. And they posted their data set on one of the resources. And it was quite interesting to start with exploratory data analysis. So to really look into the data set that HR created and understand why people leave this company. So where we started to measure attrition, we of course defined the features, we trained the model and got some reasonable results. But finally, I read this, oh, this data set is fictitious. And actually, it's happening quite often in professional life when the company is telling you A, but when you join the company, you will face B. And then I was thinking, okay, if that is the reality, so usually when the company is selling herself or himself, so how we can get the real data? And the idea was to use the scraper. And we said, okay, but let's open some resources like Glassdoor and really learn what the company is. And that is how my journey continues. So because I use NLP and I really believe that language is reflection of ourselves. Because we communicate, we do something, but now we are living in the new world. Sometimes we don't even able to see each other, so we don't have a tool to judge on how we are doing these things. But people still communicating, and communication is usually the problem for many projects that cannot happen, or vice versa. If it's efficient communication, then team is really progressing and moving forward. So what we did here, we said, okay, maybe it's too ambitious to collect the data from open sources about the company, but why not to spend some time and collect the data about the potential candidates, or what we call talent here. And I spent maybe 1 week or 1 week and a half trying to build the scraper for LinkedIn. Oh, I cannot say it. I don't want to promote any for one of the professional platforms. And really give up, because as I understood that currently most of the platforms are offering open API, and you cannot really do it from the notebooks. And I'm not a coder, so I've been working in IT department 20 years ago, and now I'm doing something else. But what is the good thing about the technology? There are a lot of tools available in the web that potentially are free of charge at the beginning, and you can just try them, understand how they're working. And I found one of them. And I selected some profiles. So here you see mine. And I really understood that when people present themselves on the professional network, we don't present ourselves in a way that machine can understand who we are. And one of our classmates in this cohort, he asked the question, so is there any solution where AI, artificial intelligence, can help to improve your profile on professional network? And as far as I know, I don't know any. So we started to work with the data sets that we created ourselves, let's say like this. And I look, one of my favorite quotes from the person that I never met, but maybe it will be one of my dreams to meet him one day, if it will be an opportunity. He was always saying one thing, that among all the qualities, one of the things that probably values the most is integrity. And that is also a little bit related to the profiles we are creating in the networks, where we are saying we are Superman or Superwoman, we are super skills. And sooner or later, someone will figure it out how it works, and maybe you're not the person who you would like to be. And the same about the company. So that was my inspiration, together with a team, to build something here. And what I've been also doing, I will show you more technical details later on. I've been interviewing a lot of HR friends and professionals to understand how we really recruit. because usually when you go to the CV or any presentation, I've been recruiting myself a lot of people. I usually looking for the personality. I'm not interested in any hard skill because I believe that you can develop. And what we did, we interviewed a number of HR professionals, and one of my favorite quote was that I asked, how do you really recruit? And they said, yeah, we can just look, do we like person or dislike? And after that, we are matching the salary. So, and if you're thinking about that that methodology can influence your career very much, you're really thinking shouldn't be done by the robots, and the robots could be more objective, or technology can replace the bias and subjective judgments. And what we did here to put some professional coding language, of course, I'm not a coder, and I'm really grateful that I have one of the best mentors and coaches for this part. So we use zero-shot classification. So we use transformer pipeline to create the scores using the language. We use back of words, and with this back of words, we created the label. And we also use some vectors, and we're trying to understand with the back of words what is the distance with standard vectors. So for us was like ideal talent language will look like. So we use some sources where you can find the similar words and etc. And you can see that the only label that showed the correlation was a leader score, because usually when you present yourself, you're saying you're one of the best, you are the leader, you are a strong personality or the great manager, and this is what you usually find on the profiles. But you never know what is the personality behind. And we use the same methods as the other colleagues. So we did the model, and you see that in our case, the decision tree classifier showed quite reasonable result. But of course, the data set is not that big. And I think the most inspiring part was just to try and to see what can work and what cannot work. And I would like to share what we learned. So I think first of all, through these 5 weeks, I learned that ability and ambition, they don't go hand in hand, and time is really unlimited, not an unlimited resource. But what I enjoy myself, so I have time every morning from 6 to 8 until my kids are sleeping, so I can use the computer, otherwise they will repossess it for study, and really practicing a little bit coding, a little bit machine learning and modeling. What I understood that 98%, I put 8 as a lucky number here, of information you can really find from the open sources, but of course it takes a lot of efforts for you to structure the data. So, and especially in the modern world where the data is like old oil, as we said. And you don't need to be scared with the coding because someone always can help you, and you can really learn by doing. And what we've been doing, so we've been trying the correlation, because in business, as I understand that, it's really an asset. So when you find the correlation, you can really sell it to the market. And of course, not every correlation implies causation. So sometimes what we see, right, but it could be really wrong. One thing few colleagues already mentioned, that connectivity was definitely the key for success, especially in China, because using different tools and different collaboration platforms is not easy if you don't have a full access to them. And maybe most important thing is that the small things are making very big impact. And we've been cleaning data, and we've been trying, and finally we got something. And my final conclusion is that, like, never give up with pursuing your dreams. So it's always possible to start, and it's always possible to create. And I would like to say special thank you to our great cohort for the time and fun we had together. And I hope it will continue. Of course, to the organizer for their inspiration and sharing. And I would like to thank you to the lockdown in Shanghai, because it gave me the time to focus on things that I really love and like. And I think, like some people said, this is the end. For me, it's only the beginning. I really see the opportunity to create something great. And here is my WeChat. So you can add me, or you can find me in our alumni group. So if you see some inspiration to do something for the talents all over the world, China, other countries, to help them to match and meet the big companies and overcome subjective HRs. So please contact me. Maybe we can do something together. Thank you very much. And yeah, I'm open for questions.
Hey, that's really great. Thank you for the presentation, Sasha.
Yeah, hey Sasha. Yeah, like thanks for a very exciting presentation. Really enjoyed listening to you. Kind of like open up the Pandora box in terms of like how complex problem is in HR to find the right talents to make sure they will succeed in the company, and the company will also like fulfill the expectations of the candidates who excited about future in the company. I see that as the kind of like matching problem, right? How to match the set of preferences of the candidate with the requirements of the company. Have you looked into this problem as the recommender system? Like remember in AI101 we had like week 3 where we talked about recommender system. One of them was content based, another was collaborative filtering. Do you think like it's the way actually to go with, where like essentially you can recommend the company to the candidate, or recommend again like to the company the right candidate from the list? Yeah, like just like putting the problem in such way.
Thank you, Aidar, for the good question. I really like it because I've been really thinking how the recommender system works in all the shopping platforms, and we've been discussing in the different sessions. So I'm really amazed about Douyin, so how they're doing this and what kind of data sets they're using. But frankly speaking, when it comes to the company, I think you really need to have an objective data. Because when we leave the company, we are always saying that maybe I left the company because my mother missing me, or maybe my father want me to help. But in fact, that someone offered you maybe 20% more salary. So that is probably one problem where we can find the reliable data and real feedback. And when it comes to the talents, if you would like to recommend the talent, I think the future of work will be that you will be more like a freelancer, where you need to build your own brand. Let's say your platform is one of the opportunities to do like this. And since you have stars or ratings, of course, why not? But that should be objective. And I'm amazed also by Bilibili, where like the ratings pop up and coming from the very big number of people, and then they are becoming more objective, so less subjective. I think it's a good idea. I know how to do it, and at least in my head, with your help, it's a clear plan how to create one of the startups that hopefully not going to add the statistics of those ones who fail and being these 3% of successful ones. So thank you guys for that.
Yeah, I want to comment here. If you look at yourself as the student in the training program, first of all, the training program implies like you'll be in your stretch zone, out of the comfort zone, and you have to kind of assemble yourself to succeed, right? You have to put the hours, you have to do the tasks, you have to engage with your classmates and with your mentors. So if you think there's lots of data that stretch out in time, that kind of gives objectiveness, because you cannot fake that over some period of time. You can fake yourself in the interview, right? When you like nail that, you like prepared, like you went to the websites, you look, what kind of questions will be asked, like you even maybe paid for the consulting, so you're prepared very well. But when you're going through the boot camp, over the long period of time, through like going through lots of tasks and challenges, I mean, like this is something there definitely, like to bring objectivity of the, at least the candidate data. Then of course, like how we can like get the data from the companies. But then like, well, we have web scraping tools, and we have social media, and we have more. So definitely it's possible to solve. I mean, like with good funding here. Yeah. Okay, that was my comments. Thanks so much, Sasha, for presenting this one.
Okay, I also make a comment. Excellent presentation. Very nice work. And also, I praise your persistence against all these technical challenges. It could be very difficult. So it will be good that you find later on an opportunity to document your approach. It definitely will be useful for people that is also looking into collecting data, and they can benefit from your experience. And as these tools are always changing and such. So this is really good. And yeah, keep your eyes open for inspiration regarding new ways to connect existing data or new ways to gather data. Maybe in the future, something can be proposed to a company so they also participate in a process where collecting more feasible data is possible and things can be worked out better. So yeah, just continue on the path, and very good job.
Thank you, Mauricio. But for the knowledge, I put it, sharing is caring, of course. So that is the collaboration. You will get it, but give me some time to breathe out, because it was really like a horse race, last days to prepare everything. So Philano knows that by heart. Thank you very much, my friend.
Thibault, any last words before we say goodbye to everybody?
Yeah, hello. Can you hear me?
Yes, you can, Adeboye.
Okay, yeah, I would like to say something before we close the meeting actually. Going through DL 101 and 201 has been an experience of a lifetime. And if there's anyone in the audience who still exhibits some kind of fear, who feels that AI is a mirage or coding is so extremely difficult, I think you'll do yourself a lot of good by giving it a try. The Unpack AI team has really done a wonderful job in putting together all these training, and it's practically designed for novices and people who do not actually know so much about coding or are not into artificial intelligence. The trainings and the classes are going to take you through the process and bring out something important out of your novice nature. So I think it's worth giving a try. And I think it's something important to venture into. And on this note, I want to say a big thank you to the mentors and to the entire team. Ada and John, you've been doing a good job, and thanks for all the experiences. Thumbs up.
Awesome.
Yeah, thanks for those comments and for sharing your opinion. So let's keep the conversation open. Reach out on the WeChat group if anyone would like to continue working in these kinds of projects. The idea